Today we're dealing with the real numbering system, and you know a lot about it, but you're going to be reviewing tons of material today, and it's a quick review. So those of you at the Math Academy this summer, we said, hey, there are some days when we spend half a class period talking about something that you spent a lot of time on in algebra. Today is one of those days. Okay? So we're going to review a bunch of things. Now this says copy down the chart describing the real number system I gave you. Then complete 5 and 6 on page 45. That's this. That's the handout I gave you. So if you look at that, the chart's copied down. 5 and 6 are right there. We're going to talk really quick about real numbers. Just so you're aware, real numbers, if you didn't get the learning goal, relax. It'll be okay. Okay? Hi. Okay, so I pass them that way. I'll always pass more up that way so you guys get them. Okay, so you got to pass them up to them. Do you still need another one?
Yeah.
Is there an extra one laying around? All right, I'll find you one. Here you go. All right. Real numbers are numbers you already know. You've already dealt with them. They're every type of number you've dealt with so far in life. Back when your parents started counting with you, or whoever started counting with you, and they got all happy, happy, joy, joy because you knew 1, 2, and 3, those were real numbers. They fell under a special type of real number, which we call natural or counting numbers. And then eventually we added 0, and your mind was blown. You're like, holy cow, there's a 0? And you're like, yeah, it's our hero, dude. That is a whole number. Okay, that's the difference between natural and whole numbers. You put that 0 in there. And then eventually we said, hey, really we've told you that there aren't numbers on the other side of 0, but we lied to you all these years, and there are negative numbers. And you're like, whoa, dude, there's negatives? Yeah, and we find out that you could have debt and stuff like that. Those are negatives. Okay, negative numbers, so natural numbers and their opposites are called negative numbers. Those are integers. Okay, we have called that integers. And then all those other numbers in between all that stuff, all the fractional pieces like halves and thirds and fourths and fifths and sixths and sevenths and eighths and ninths and all those things, and all those decimals that terminate or repeat are rational numbers. Rational means it can be expressed as a ratio. A ratio is a comparison. It's a fraction. So if you can express any number as a ratio, then it's a rational number. Okay? For instance, 1/2 or 3/10. Yes, you read that as 3/10, not 0.3. 3/10. If you read it as 3/10, then you know it means 3/10, which is a fraction. Okay? So, we now have this other whole different set that you've been introduced to, mostly since middle school, called irrational numbers. Irrational are numbers that are not ratios. They cannot be expressed as fractions. For instance, radicals that can't be simplified, like root 2, root 3. Is root 4 rational or irrational?
Rational.
Yeah, root 4 is rational because root 4 is actually 2. Okay, so the non-perfect roots go over here. Pi, okay, non-perfect cubed roots and other roots we deal with this year. E, when we get to the special letter E, it goes over here. Or the special number E, it goes over there. Okay, those are irrational numbers. All right, now that's all you know about numbers. Now there's this whole other category we're going to introduce later this year, okay, which are called imaginary numbers. Those are complex numbers. That's a whole different numbering system. So you have real, and then over here you have another box called complex, which we will deal with later. Okay, so numbers 5 and 6, and we're going to go through these together just real quick as a class. If a number is in the set of rational numbers, is it necessarily a real number? If a number is a rational number, does it have to be a real number?
Yes.
Yeah, because it falls under that umbrella. All the numbers we know so far are real numbers. Okay? Now, the non-reals are our imaginary numbers. They're floating all around us, but you just can't see them yet. Okay? Later on. All right? And an integer. Does a rational number have to be an integer? No. Rational number could be outside of that integer area. It could be, give your neighbor an example of a number that is not an integer, but it is a rational number.
Half. 1/2.
Heard a lot of halves. Any others? Yeah.
A quarter.
A quarter. How about negative a quarter?
Yeah.
Yeah.
Negative a half. Wow. Okay. How about, does a rational number have to be an irrational number?
No.
Can a rational number be an irrational number? No. They don't have a common thing. Okay? If it's rational, then it's not irrational. And if it's irrational, then it is not rational. It's like when you throw a fit at home. You're either being irrational, you're throwing the fit, or you're being rational. You're not throwing the fit. Don't throw fits. Okay? Number 6, is the set of whole numbers a subset of the real numbers? Okay, go ahead and answer number 6 with your groupies. You have about 30 seconds. Talk about, is the set of whole numbers a subset of real numbers? Yeah, all whole numbers are real numbers. Are all whole numbers natural numbers? No. Are some whole numbers natural numbers? In fact, all whole numbers except for 0. Okay, 0 is the one that is not a natural number. What's that?
So it's not a hero.
Well, it's my hero. Yeah, I just want to say. Negatives are not whole numbers. Or, what's that? Okay. All right, moving on. Any questions there? All right, next thing I want us to do. We're moving past this. We're going to dive into some more specific types of numbers. First, I want you to decide with your groupie, is that rational or irrational? Ready? Go. Actually, how many say rational? How many say irrational? Okay, you got to pick a side. So most of you said irrational. Let's check it out. Remember, a root that's a fraction that's in a radical, we can break down to root 25 over root 36. And root 25 is?
5.
And root 36 is?
6.
Rational or irrational?
Rational.
That is rational. Okay. Now, let me pause you. A couple things to take away from this. Remember, I said today we're covering a lot of things that you learned in algebra and in previous classes all in one day. We simplified radicals before. You know that, or you've learned at some point, that anytime you have a fraction under a radical, you break it up like this. Sometimes that denominator is perfect, which you like. Sometimes it won't be perfect, which you don't like. Okay? So we'll get to when it's not perfect at some point. Okay? But for now, this is rational. We're able to classify it as rational. Okay? Any questions there? Okay, very good. Moving on. Actually, I don't want to do that one right now. Not too worried about that. All right. Why don't you try number 15? Okay? There you go. Work on your own.
Just fine. Same as if it's
Leave it as a radical. Yep. All right. Can I please have your attention up here? Hey, very good, most of you there. So, first step, what do we do? Tyler, what do you got?
You either add 17 to each side or subtract 9x squared from each side.
Okay, so maybe you move the 17, okay? So the goal is to collect the variable on the same side, so move other things away from the variable. That gives me what over here?
9x squared. That's 24.
Okay. And what's left on this side? 21x squared. Okay. Let me zoom in on that. I know it's kind of blurry. So, all right. Next step. Parker.
Subtract 9x squared.
Subtract 9x squared. So collect our variable on the same side. And that ends up with what left here? 24 equals 12x squared. Next step. Anna. Divide by 12. So on this side we're left with?
X
X
squared.
squared.
Equals 2. All right. Now that's what I expect to see. You don't have to show the plus 17. You have to show the minus 9. If you want to leave this out and just go from here to here, here to here, here to here, that's fine. What's the next step? Square root, my answer is? Root 2. How many got that? Now, that would give you half credit on your test. You get 50%. You get at least 50%. That's better than 0%. Tyler?
Would you have to say if it's rational or irrational? Or
No, it just says solve and check. I mean, I don't make you show your check. You can, if you don't check your work, then that's your bag. But I'll show you how you can here in a minute. But you're missing half your answer here. Tyler?
would it be root 2 negative root 2 or something?
Yeah, it'd be plus minus root 2. Positive root 2 and negative root 2. Now, some students will go, hey, I thought a root can't be a negative. Well, you don't have a negative inside the root. The root's on the negative's on the outside, and actually later on we'll have a negative inside, and that's when you get those imaginary numbers. But right here your answer is positive root 2 and negative root 2. Now the compact form is plus minus root 2. Now remember, anytime you impose a square root, you start a problem without a square root in it, and at some point you put a square root in it, you have to put plus minus. That didn't come into play much in geometry because geometry, you're dealing with length all the time. And the negative, you don't have a negative length. In algebra, you get a lot of negative numbers, and you can have a root that's negative. Okay? It's like having negative 1 times root 2. All right, now, for those of you who are like a little confused on that, just take this for example. X squared equals 9. Okay? When you take the root of both sides, you get x equals 3. That means if I plug it back in, 3 squared is 9. But really, negative 3 squared is also 9. Right? Negative 3 times negative 3. That's why the positive negative. Now that obviously has nothing to do with this problem other than the plus minus piece. Okay? Now if I'm checking these answers, I would go back up here and I would do 21 times root 2 squared minus 17 equals 9 times root 2 squared plus 7. Now that brings up a good point. Anytime you square a root, what do you get?
You get an integer? No.
Anytime you square a root, you get the thing
It's
inside it, right? Root 2 times root 2 is root. Oh, so I see some of you zoning out. I see some of you not answering. I don't know if you know it or not. Root 2 times root 2 is root
4.
root 4. And root 4 is 2. So you get the thing inside. So really this means 21 times 2. Minus 17, which that's 42. Minus 17 is 25. Okay? Root 2 times root 2 is 4. Root 4, which is 2. So we get 9 times 2 plus 7, or 18 plus 7, or 25. And if I put the negative in here, notice what a negative does. A negative squared is positive. If I put the negative here, you square it, you still get that positive too. Okay? So that's why that works. That's how you check your work. All right. Questions on that?
Wait, do you grade
Go.
us half a point down if we don't check our work?
I don't need to see your check. If you don't check your work, you guys are now to a point where, dude, that's your bad. Because, man, I'd be checking my work all the time. See if I get the right answer. It helps you on your tests and quizzes. Okay, I don't need to see your check. That's up to you to do. Okay, any other questions? Some teachers really want to see that every time. I don't need to see it. All right. Attention up here. So you have your assignment. You're going to first start by crossing out the example side. We won't be doing that today. Okay. Please remember, you got to finish up 1-6 if you haven't done so. Most of you at least have the setups done. That's good. On the mixed side, you can cross out problem 2. Okay, we don't need to do that one. All right. So what I'd like you to do to begin with is I just want you to read through each set of problems. Obviously 1, 3, and 4 you should read through on your own. The directions for 5 through 14, directions for 15 through 39, 40 through 42, and 43 through 51. Just to make sure you understand what's expected on each of those. Here in a minute, I'll find out if you need some, if you have some questions, and then there's a couple things that I need to cover on here with you. Okay? So do that right now, please, on your own.
Can we abbreviate it by putting R or IR?
Okay, yeah, so the question on 15 through 39, if you're abbreviating for I or R, you can just put I or R for rational or irrational. That's fine. One of the problems I wanted to cover with you is 15 because it says simplify the radicals, and we spend a lot of time in that in geometry. Some of you, I assume all the geometry teachers covered it. Some of us forget it over the summer. So let's simplify root 28 together. Root 28, I want you to simplify what you remember from simplifying on your own right now, okay? Then we'll do it as a class. And what do you got?
Okay, so when you're simplifying a square root, you want to break it down into parts in which it, well, like two numbers basically that multiply to get what's inside the square root. So in this case, it'd be 4 and 7. And 4 is a perfect square root. So you could break that up even further, which is 2, and you pull that out of the radical, and you're left with 2 root 7.
Good. Okay, so you're looking for, very good explanation. Okay, 2 times root 7. You're looking for a perfect square that goes into that number. So you test the perfect squares. You test 4, you test 9, 16, 25, and so on. Okay, you try to find the perfect squares that go into that. So really, if I want to simplify root 28, is it okay to use root 2 by root 14? No, because neither of these are perfect. So this doesn't work. That doesn't help us at all. Okay, you have to use something that's perfect. Now sometimes more than one perfect goes into it. Like if you had, say, root 64, I know that 4 goes into that. I know it goes in 16 times. Okay, right? 4 by 16. Okay, in that case, I have 2 perfects that go into it. That gives me 2 and 4 or 8. Or you know that 64 is perfect. Okay? So there's different ways. You look at it and go, man, 64 is perfect. I could have just went from here to here. Yeah, you're right. You could have. You could do like root 32. If I had root 32, 4 goes into that. How many times? 8 times. Well, that gives me 2 root 8. Well, you better be careful because is 8 perfect?
No.
Okay. But it can be broken down, though. A perfect goes into it.
Yeah, 4 and 2. And then pull out 4. Or 6.
So 2 root 2, and this 2 comes down here. So now we have 2 times root 2, or 4 root 2. You guys got to tell me if I drop off the screen there. Okay, 4 root 2. It could have been quicker if you would have just said root 16 by root 2, right? Because that gives you 4 root 2 right there. But either way, you get to the answer. Okay, other questions that you saw? Okay, the last thing I think you need to make sure you're clear on is right here on part number 1, part A. Well, there's 4 parts. This is not a multiple choice problem. Right? You don't just say, hey, the answer's A. All right. Okay? Approximate time in seconds that it takes an object to fall d feet. So d feet, time in seconds, under the influence of gravity is given by this formula. So this is where math is the language of science. You have to understand how to work the math to do the science. Find the time it takes an object to fall each distance. Well, if it's 16 feet, 16 goes in for which variable? D. So you plug that 16 in there, you end up saying t equals the square root of 16 over 16. If I were you, anytime I'm dealing with a fraction, try to simplify it if that would be helpful. In this case, I think it would, because 16 divided by 16 is 1. So the root of 1 is 1. 1 stands for 1 second, right? 1s, and put a cool s with little tails, otherwise it looks like 15. Okay, that's it. Sure we're clear on 5 through 14, give the most specific name, right? So like root 9 simplifies to 3. 3 is a real number, but more specifically, right, it's an integer, it's rational, it's an integer, it's a whole number, but the most specific name is a natural number. So tell me it's a natural number. Okay?